unit, so or chapter. So let us now go into the regular. So let us say you consider a simple bar. Okay, so let's say there is a prismatic bar like this. Okay, what do you mean by prismatic bar? Anybody?
Sir, sir, sir.
What is the meaning of prismatic bar?
Yes, sir. Yes, sir.
Hello, anybody?
No idea, sir.
No idea. Okay, tell that. No, at least. Okay, so prismatic bar basically means,
Okay,
one
okay,
second before I tell what is a prismatic bar. So let us say there is a load, a tensile load that is applied like this. A prismatic bar, okay, refers to a bar that is
no, sir.
of of a kind of a prism.
We kept earlier like that only, sir. So Tiwari sir said
In
like that.
EED, you would have
Once
discussed
Tiwari sir come
various
back, we can ask him.
types
We
of
can take
prisms, isn't
interview
it?
also.
So you have
So this one
triangular
Tiwari sir,
prism, you have
he is okay to
square
that one and
prism,
whatever it is there, we'll go ahead
pentagonal
with this one.
prism,
So just he has made
right?
like suggestions.
So
So
for
just see
example,
that
you
this is
have,
also one of them.
so something like this, a triangle, equilateral triangle, right? This is a triangular prism. Similarly, sorry,
Where sir has come, sir.
right?
Sir,
So,
your microphone is mute, sir. Rudranayak sir. Okay.
so this is a square prism. Like that, you will have pentagonal prism, rectangular prism. So a bar of that shape is what is called as prismatic bar. Now, a prismatic bar is also valid for a cylindrical bar too. Okay, a cylindrical bar is also a prismatic bar. Why so?
It's a circular prism.
Basically, yeah, it's a circular prism. It's a prism with infinite number of sides, isn't it? So that is also there. So anyway, we are considering one prismatic bar. This you people already know it, but maybe you never heard of this term, I guess. I'll just draw one axis line also. Okay, just to show that the load is applied along the axis. Okay. There is one more concept here. This whatever load I have, this particular arrow, this arrow that I have drawn on the other side, they are indicating total load on that side or that face of that particular bar. Okay, not that a load is a point load is being applied, isn't it? Okay, so because there is one more theorem that we will come across called Saint Venant's theorem. Sometime later I'll discuss. So there we will see what is the effect of having a load at the end and all. So, but anyway, here it is nothing but it's just indicative, a kind of what you can call um, just a figure that is being
Sir.
shown. The load may be applied throughout the face. Okay, now let us say this is the tensile load, and as a result of this
Fine,
tensile load, let's say the whole
yes, sir. I'll
bar
get back on this one.
gets
So now, sir,
extended like this.
Tiwari sir has suggested a few changes in the
Okay, I will just draw the whole line once again
template of the front
because
front
in
face.
yesterday,
So
in
already
sorry,
he
in
have
the
made the
previous
changes in
class,
the front
we
face.
have seen the
So whatever the
effect
changes
of
he has
a
asked me to
tensile load
do, I
that it
have made
also
in the
causes a lateral strain.
place. So
So
small
keeping
changes
that
we
in
are
mind, I
making
am
here
drawing
in
one.
the Department of Mechanical. Then I'm working here. So so the
Okay,
front page has been
so
changed
let's
accordingly.
say,
So just anybody have any comment on this one, so please tell it, sir, so that I can make it. Sir. Well, okay, I'll zoom the part. Oh, okay. So this is the current the date which we have planned, sir, and based on the discussion which I had in the last
okay,
meeting.
so let us say this is L.
Oh, okay, okay, I'll change it.
L plus delta L.
changes.
Okay. Let us assume that, so the given length of the bar is L.
Changes in the original
Let
price.
us say, let A be the cross sectional area of this
Original
particular
price. I will
bar,
change it. Okay, I will change the
and
original
let
price.
E be the
Sir, I am taking
Young's
note of it and I am
modulus,
changing in the original price.
Young's modulus
Okay, okay.
um, of the material of the bar, right? Right. Now, assuming that this load P is within the elastic limit, so we know that
So
within
December
elastic
16,
limit,
18, 2021 is the day, sir. Correct. And this is in memory of Professor J.S. Rao on the occasion of celebrating 25th year of BMS
within
Council,
elastic limit,
organized by Department of
you
Mechanical
have
Engineering and Department of Aerospace Engineering and
sigma
Engineering
is
Bangalore
equals to
in association with the Vibration Institute of India and the
E epsilon.
Indian Institute of Technology.
Correct?
This
Its
is
sigma is
the
directly proportional to epsilon.
initiative status.
We also know that sigma is
Later,
equals to
whatever
E epsilon.
changes
Right?
or
This is
whatever
what
updates will be ensued from the
Hooke's
officer,
law states,
so
isn't
accordingly
it?
we change
So now this implies what? What is sigma in terms of the figure that you are seeing?
since the topics,
P by
what are
A.
the topics,
P by A.
and now
So it
Diwali
is
sir has given the suggestion to segregate it. So based on your input, do I need to keep same thing or do I need to make a segregation? So based on that one, I will note down and I will make the changes accordingly.
then you
E,
have
e
E into epsilon.
Sir, I'm making sir.
What is epsilon?
Sir.
delta L by L.
Delta L by L. Right? So now, come to think of it, most of the times in 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 real time applications or in any particular given conditions, what all we will be knowing in this whole in this complete equation, what all will be known to us. We will know the load applied P. We will definitely know the cross sectional area. We will know what is the length. Now, generally, two things that we may not know. Number one, it could either be E or it could be either be delta L. Now, for a given material, okay, we also know many a times it is very much possible that we already know the E. If it is a known material, if it is a material with predetermined values, then E also will be known. So what is unknown now? Delta L, isn't it? The delta L
Sure,
is
means
the unknown
correct that
quantity. So we have to now rearrange this whole thing for the unknown quantity. If you rearrange all the terms, what will you get? Delta L is equals to
agree, sir. So the current format is okay. Only I have to bunch together the tape.
PL by AE.
Okay, sir.
PL by AE. Have you earlier only arrived at this particular formula? Do you know this particular expression from your previous knowledge?
Sir,
Sir, expansions of solid, I think.
1 minute, 1 minute.
Expansions of
Sir.
Solids.
Sure,
solids.
sure, sir.
Where have you discussed this
I
in
will change my
physics?
location, sir. Can you give me 2 minutes?
Plus 2,
Yes,
yes,
sir.
sir, physics.
Yeah, 12th.
You talk about
Huh?
website, sir. So I'll change my location and I'll practice.
Multiple
12th
people.
standard,
Yeah,
yes,
yeah,
sir.
yeah. Sure, sir, sure.
While the
Okay.
rod is being heated and it is forced to stay in a particular length.
Okay. So there you have seen this. Okay. Fine. So anyway, so now, so this is delta L is equals to PL by AE. Okay. So now let us try to work with this particular um, formula to get some. Uh, One second, just let me. So this is standard formula that you will get in. One second, just there's some small distraction here. Okay. Okay, so let us take into account this particular uh, numerical. I had told in the previous class only that you people need to be ready with a calculator and even paper and pen to do some calculations. So I hope you people are having that. Now, one thing before I proceed with this particular question is this particular formula that you are seeing, the enclosed one. I think this is the first, formally, officially, this is the first formula that you will come across in SOM, and it is often told. This is what was told to me by my teachers during my engineering study, that no matter what, you cannot afford to forget this formula. Okay, delta L is equals to PL by AE. You will encounter this formula everywhere, and no way you are supposed to forget this. Even if you for some reason, like you don't after becoming mechanical engineer, you don't pursue a profession in this particular field. Also, you are not supposed to forget this particular formula. That's the kind of what you can say, the uh, nature of this formula. So that I'm just transferring the same thing to you. So even if you're woken up you know in the midnight from your deep sleep, you should be able to tell this particular formula without even thinking once. That is the idea with which this formula is always proposed to students. I'm just doing the same thing for you. So now let us try to focus on this particular uh, what you can say, the question. So you can read the question. I hope you people have already started reading the question. So there was a we have seen this 10 side test earlier in our discussion. So I have taken the same query, same question now. So a 10 side test is conducted on mild steel bar. That is the type of material that is considered, and the diameter of the steel bar, that is that particular mild steel bar, is 3 centimeters. Gauge length of the bar is 20 centimeters. Load at elastic limit is 250 kilonewton. Extension at a load of 150 kilonewton is 0.21 mm. Maximum load is 380 kilonewton. Total extension is 60 mm. Diameter of the rod at the time it failed is 2.25 centimeters. Okay, you are required to determine four things. That is number one, Young's modulus, then elastic limit, percentage elongation, and decrease in cross sectional area. So these are the things that are to be found out. Okay. Now I'm sure when Professor Sangamesh sir has discussed in fluid mechanics, he has been telling you that you should adopt a methodic approach of solving numericals, and I definitely second what he has told. Uh, you should always be very very ordered and what you can say, methodic in, especially when you're solving numericals. It applies to everything, even when you're writing a descriptive theoretical answer also. This we are telling with respect to your answers in internals, or that is test and final exams. But nonetheless it applies everywhere, but more so in test or exam. And you should always follow a definite what you can say, order and method to solve any problem, or theory as well as numerical, but it applies more so for a numerical problem. Okay, so now the first thing, as Professor Sangamesh should have told you, is to note down the given things. Of course, the question is right there in front of your eyes. So sometimes it may appear like, what is this? It's already there at that particular thing. It is very orderly. Of course, the question, it so happens here that in this question, the data given is itself is in a very orderly fashion. But nonetheless, we will start noting down the given data. So you have first thing that has been given, diameter of the rod. So diameter, let us say I will denote it by small d or capital D. Now one thing which you have to observe, uh, which I am going to show you now, whenever you are writing the given data, you have to write it in a very consistent units. You have to bring all the data into consistent form. So that you should learn. So like right now we are following what we are following SI system of units. So centimeters, okay, and kg, and foot, and maybe inches. All these are not allowed. Okay, question may contain, see, don't say that question itself should not contain, question may contain, but while you are calculating, while you are doing the work, you cannot take the required I mean, you cannot take any data, any unit that is given randomly. So you have to convert it into corresponding SI form. So 3 centimeters. Now let us, as I have told you earlier also, we will stick to millimeters. And since already in this particular question they have given one data in millimeters, so I'll convert this also into millimeters. So D should be how much?
3 into 10 power minus 2 meter. Oh, millimeters, sir.
Hmm,
30 millimeters.
30 millimeters. Right, that is the idea of using millimeters. Why? Because as mechanical engineers we don't deal with meters. The components that we come across and make use of are all limited to within less than zero point 0.1 meters, that is 100 mm. So it should be okay to work with millimeters only. Now one general request to the whole group. I have already now taken about 5 classes plus one interaction class. I've seen that generally some 4 or 5 people will interact. Okay, like for example, it may be Sumedh, or it may be Tanmay or Yuvaraj or Vishnu Pratap, or sometimes sorry, Tejas, Shashank, some 5 6 people. Sometimes even Fadil will open up his mouth and tell something. Good, that's good. But what about others? Others also I think should try to interact. So this is a very good time to show your involvement and commitment, or rather interest. So I request others also to start along with me, calculate as and when I am writing. You also note down, calculate, and tell the answers when I ask the answers. Okay, so when I say tell the answers, so I want now, apart from these names that I just took now, okay, so I want others also to pitch in with answers. If you are shy to speak up, unmute and speak up, you can just type in the chat. Okay, but while actually you should not be shy to speak up also, that's actually not a great thing. Being shy to speak up when it is required is not a great what you can say quality. But nonetheless, if you are really so shy, you don't want to open up your mouth at all, no problem. At least in the chat window you can type in the values, right? Okay, so let us now continue. So you have D equals to 30 mm. Then they have given gauge length. So gauge length is 20 centimeters. So which means it is 200 mm. Okay. Then load at elastic limit. Let us say elastic limit. I'll just say elastic limit, and I'll just say P elastic. Okay. So it is given as 250 kilonewtons, and I'm sure uh, uh, even in your fluid mechanics you would have seen this usage of K, usage of N, all those things. I hope you people remember. See, kilo, K is small. Okay, so I'll just write down some of the things that you people should know. I usually do it in the beginning, but anyway, it doesn't matter, beginning or somewhere in between, wherever it is applicable I will show that. So you have uh, this is what prefix? This is micro. If you have small m, I am talking this in terms of whenever you are writing any units. Okay, prefixed to units. So small m is milli. Okay, then small k is kilo. Capital M. What is capital M?
Mega.
Mega. Okay. By the way, I hope these things are known. This is what micro is how much? 10 to the power minus 6. Milli is 10 to the power minus 3. Kilo is 10 to the power 3. This is 10 to the power 6. So, okay. Capital G is
Giga.
giga. 10 to the power 9. Okay. So it is 250 into 10 to the power minus, sorry, not minus, I'm sorry, 10 to the power 3 Newton. Okay. So this is fine. Then elastic limit load is done. Then you have extension. So extension at 150 kilonewton. Okay, so you can say delta L extension. You can denote by delta L at, we can just say P equals to 150 is equals to how much? 0.21 mm. Okay, then I will write the other things here so that I can have the question in my view, or rather in your view. I can somehow view the question, but maybe you people have not noted down the question. So maximum load, maximum load. What do you mean by maximum load? P ultimate is 380 kilonewton. That K that I have written is small. Okay, so is equals to 380 into 10 to the power 3 newtons. Then, okay, then what else is there? Total extension is delta L final. Delta L final is how much? 60 mm. Okay. Diameter of the rod at the failure. So you can say final diameter. Okay, you can say this, you can not make it as di, saying that it is initial diameter. Then we can note down this as the final diameter, which is nothing but 2.25 centimeter. Okay, that is, sorry, right. So this is the set of given data we have, right? 7 data have been given, 7 data we have written down. What all we need to find out? We need to find E. Then we need to see sigma elastic. Then we need to see percentage elongation. Okay, and last one, percentage decrease in cross section area. Right, if you write this much, don't say you will get some marks. No, you won't get some marks. If you write this much, your half the troubles are taken care of. Oftentimes Okay, in this particular question that you see, everything is very orderly given and you don't have to bother much. It's as good as like I have just repeated the question, except for some the except for some small this one articles and all those things, in this sentence, right? So that is the only thing now. But in many problems you will see further down the line, you will not have data given in such a orderly fashion, everything mentioned in uh, one after one another. So in such cases, writing down like this makes a lot of sense, right? Okay. So now let us start one by one. So what is the first thing that you should do?
Formula.
You have to write the formula, but before you write the formula, some things that you can do, what is called as some initial calculations you can do. For example, okay, area initial AI. See, for calculating sigma, you require area. For calculating decrease in cross section, this one you require area. So for these things, you require calculation of area, so that you can calculate without bothering what are the other formula. You can just calculate that. So initial area is pi di square by 4. Okay. So can anybody tell how much is this pi di square by 4? Hmm?
Sir, 7 into 10 power minus 4 meter square.
1 second. Um, who was that who answered?
Sir, me, sir.
Yuvraj, okay. Yuvraj, what is the number you told?
Sir, 7.065 into 10 power minus 4 meter square.
Why suddenly you converted into meter?
Sir, I kept everything in SI unit, sir.
This is millimeter is also SI unit, pa. Hmm? You are
Yeah.
seeing that you are so you are saying your indication is that I am not using SI unit, is it?
No, sir.
No, no, the way you told it means that only, that implies that only.
Sir,
Anyways.
I mean, like, if we take newtons and all, we'll take meters, no, sir. So I neglected
I told
mm.
you, no, why I am not taking meters or why we don't take meters. You are not listening to that part. I've
I
told
was,
today also. I've told some time back also when we were discussing stress. When we discussed stress in the first class, I gave units of stress. I have there also. I've told, right? Okay. So I want you to recalculate and tell me in millimeters square. And I think Indraj, you could have already calculated. What about others? Let's say somebody.
Sir,
Sir, I've got the answer of
okay.
Young's modulus, sir.
Sir, 7 not 6
No,
point
okay, okay. I know you would have got. Yes, Vaibhav.
7 not 6 point
706.
706.85 millimeter.
point.
Very good. Okay, 85 millimeters.
Millimeter.
Millimeter.
Millimeter square, not millimeter. Not millimeter. See, if you write millimeter instead of millimeter square, if you write like this, immediately what I will do, not only me, anybody else will do is, we will cut 1 marks here. We will say minus 1 marks, assuming that 1 marks is allotted for calculation of area. Just because you have written the unit wrong, we will deduct 1 marks there. We are all, you can say, like trigger go happy guys. Okay. So we will be searching for chances to deduct marks. So the more chances you give, the more happy we will be. Right? So ensure that you don't make any mistake in units. So this is not millimeters, it is millimeter square. Hmm. Okay. Similarly, A final. Okay. A final. How much is A final? That is nothing but pi df square by 4. This
So 397.4.
397.4.
4.
607.
397.40.
607.
How 4?
397.607.
607. Please be careful about decimal parts. Decimal parts also play a lot of importance. I'll show it to you. May not be in this particular case, but once you make a mistake somewhere, you'll carry that mistake like that for every other cases also. Okay, so that's why you should be clear. I mean, should be careful and as well as observing. You should never make mistakes in decimal parts. You should write, to the nearest possible accuracy and correct numbers. No truncation, no unnecessary conversions and all. Okay, fine. So these
Sir,
are the two things
sir,
that
actually we
yeah.
are getting 397.4, sir. It's
No.
3.14 into
Hey,
22.2.
hey, hello, 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 hello.
Sorry,
Suhas.
sir.
Okay, and not only to Suhas, to everybody else. I hope you people are all carrying your scientific calculators.
Yes,
Anybody
sir.
who's working with some that Kirana shop calculator, if you are calculating with Kirana shop calculator, I please request you to stop calculating or immediately fetch a proper scientific calculator. Never use pi equals to 3.14. Using pi equals to 3.14 is okay for jokes, but not for engineering students or engineers. If you are using pi equals to 3.14, you are not an engineer. Now you are not a BE, of course, but you will not be an engineer also. Do you understand? Never
Yes.
ever use pi is equals to 3.14. You should. I mean, I thought you would know this by now. You should use 22 by 7. No, heck, don't even use 22 by 7. There is a pi symbol in your calculator. You want me to tell where it will be?
It's there, sir.
No, it will be near the equals to sign. Equals to button will be there, near either
Yes.
on top of it or to the right of it. There will be a pi symbol. Please use pi symbol everywhere, everywhere. Okay, without fail, without any exception. Not only in SOM, in any other course, never ever use pi equals to 3.14. That is pure stupidity, right? Okay, you may feel that what this guy is using profanities and all, but it is so, right? So please avoid such mistakes. Please use pi, the actual pi that is your calculator is giving. Or if you don't want to, so for some reason you cannot use that pi button or something, use 22 by 7 at least. Okay, right? Okay, so we will go ahead. So these are some initial calculations, some what you can say preparatory calculations that you can do. And then now we can already many people have gone ahead and done some calculations also. I'm holding them back. So they are a little getting impatient. So let us now go into the first one. First we have to find out. So what we have to find out, what is the first thing they have asked? Young's modulus. How to find out Young's modulus?
So rearrange in the same equation which you wrote above, sir.
Which one? Delta L is equals to PL by AE.
Yes, sir.
Okay, delta L is equals to PL by AE. You want to rearrange. Okay,
Yeah,
so
sir.
let me rearrange this. So you are saying E is equals to P into L by AI, or should I take AF?
AI, sir.
AI into delta L. Which delta L is this?
Sir, it is the delta L at P equals to 150.
Yes, we are going to make use of this delta L. Okay, so that is this P is equals to 150. So what is this P?
150, sir.
150. Very good. So that means, so this becomes,
Kilonewton.
yeah, 150 into 10 to the power 3. Okay, I am removing that kilo and I am putting 10 to the power 3, even though nowhere in the given data I have mentioned it as anywhere 3, but here I am going to internally make use of that. Into gauge length only I should use. What is the gauge length? 200 millimeters divided by AI. I can just put 706.85. If it is very close to, if it is like 859, then you can make this as 86. 706.86 you can make, or otherwise 706.85 is fine. Into delta L. How much is delta L? 0.21. Tejas, what is the answer for this? Wait, Tejas. Let us see if somebody else can give the answer. I know you have already have the answer. So, anybody? Nandan. Hari Yadav, any one of you? Yes, Nandan, Hari, you can at least respond saying, sir, we are calculating, we are doing, sir, we will tell, sir.
We're doing, sir. We're doing.
Yeah, do it quickly and tell the answer. Yeah, Hari Yadav has already given the answer. Very good. Let us see. 20. 1 second. He has typed in the chat. Okay. So, what is it? 202. Okay. 103 point. Very good. Correct. So, 1 second. I will just write down 202. 103.9. Hari Yadav, what is the unit? Hari? Varun G has told it is 202 GPA. Okay, good. But I am just waiting for Hari Yadav to tell the units. Or maybe Nandan can tell the units at least. Okay, Hari Yadav is telling it is Newton per meter square. You people, do you agree? Is it Newton per meter square?
No,
Millimeter.
sir.
Again, Sushant is also saying Pascal. Pascal is nothing but Newton per meter square. Unfortunately, no. It is not Newton per meter square. It is Newton per millimeter square. Please observe, nowhere in this whole thing we have used meter anywhere. Okay, 150 into 10 to the power 3 is in newtons, 200 is in millimeters, 706.85 is okay. Let me write it out. I think if I write it, it will be easier for you to. Okay, let's say this one. So this is in. I'm going very slow. This is not the usual pace at which I solve problems, but because this is the first problem, I am taking time. So it is Newton, then 200 is millimeters, then this is millimeter square, this is also millimeter. Okay, Hari Yadav and Sushant saying, Sushant, good. At least you responded, even though I did not take your name, you responded to that query. It's good actually. So it is not PA, it is not Newton per meter square. See this millimeter and this millimeter, they strike off or they cancel out each other. So what you are left out is Newton, sorry, Newton per millimeter square, or what is Newton, 1 Newton per millimeter square, also known as,
Megapascal.
huh? Padil?
So 1 megapascal.
Megapascal, very good. It is 1 MPa. 1 Newton per millimeter square is MPa, is 10 to the power 6 Pascal, is 10 to the power 6 Newton per meter square. Or Vignesh, what you have written is not correct. It is not 202.103 MPa. It is 202.103 or 104 GPa. What this guy has mentioned. Oh, who? Varun. What Varun has mentioned, 202 GPa, 202.104 GPa, gigapascal, not megapascal. Okay, is this fine? Okay, so let me proceed further. As I told, I'm going rather very slow, but okay. If you get the concepts by going slow, there is nothing better than that. So, what is stress within the elastic or at the elastic limit?
F by
F by A, P by A. Again, I am very particular about notations what I am using here. We have stopped using F by A, F. It's P, load. Okay, especially in this, at least this problem, you cannot use F because it is load. Stress, it's a stress strain experiment, it's a tensile test experiment. So there is no concept of force, it is load. Okay, so now P by A, what P should I take?
So 250.
We have to take P elastic, what I have written down there, P elastic, and this AI is AI. Okay, so 250 into 10 to the power 3 divided by 706.85. Who can tell the answer apart from, sorry, where did it go? Apart from that,
350.
Shashank is telling what number?
681.
One second.
353.681.
677. Okay, so 353.677 units. You have to, the moment you tell some number, you have to accompany it with units until unless there are no units to that number.
Newton per meter square.
Newton per
Millimeter square.
millimeter square, not
Some
meter square.
millimeters.
Sorry, Newton per
Newton
minute.
per millimeter square or MPa. Okay, 353.677 okay, 36677. Wherever possible, maintain three decimal places. Okay, second decimal place also you can sometimes convert. Okay, then percentage elongation. What is percentage elongation?
Delta L by L into 100.
Delta L. What delta L?
Change in length.
LF minus
Final delta.
by
Change in length.
Li into 100. Change in length, you may have different change in length. For example, here in this case, delta L is 0.21. So this is also change in length. You want, this is the percentage elongation?
No, sir. Final change in length minus
Final
initial.
and
That's why LF minus Li, you should say. Fine, there's no final change in length minus nothing. Final change in length, but final change in length is what? LF minus Li. Okay, LF, basically now they have not given LF separately. They have given LF minus Li. What is the LF minus Li they have given? Delta L final. That is the one that they have given. So you have to do, so that is nothing but delta L final divided by Li into 100. So that is nothing but 60 divided by 200 into 100. How much?
30.
30%. Okay. So these are all the final answers. Okay. Then last one is percentage reduction in cross section area. Okay.
Sir,
Is equals to
is it
what?
43.7?
AI, first you have to tell the formula, AI minus AF, not AF minus AI. In tension, in tensile test, it is AI minus AF. Why AI minus AF?
Initial area will be greater, sir.
It will be greater. Initial area will be bigger. So divided by AI into 100. Remember one thing, sometimes I have seen some students, due to confusion or due to, I don't know for what reason, they will get confused. They will use LF instead of I, AI, AF instead of I. Please don't get confused. It is always initial area, initial length. Whenever you are saying any percentage calculation, it is always with respect to the initial value. Remember this. Okay, mostly students don't make mistakes in this one, but sometimes, due to whatever reasons, I don't know, they will make this mistake. So what are the values here you have? So 706.85, that is, so 706.85 minus 397.607. 397.607 divided by 706.85 into 100. Hmm. Already, I think who told? Tanmay told or somebody told the value. What is the value that you people told?
3.7.
Yeah,
75.
sir.
Okay, 43.75 percentage. Okay, fine. So this is how you calculate, you do this, you write the formula, you substitute the values, and see, I have seen, for example, like you take this one other thing that I want to highlight, and then we will end this class. So you take this calculation, you take this calculation. Here I have seen, one set of students, they won't even show what are the value substitutions, and they will give this final answer. That is one set of extreme students. Then there are other side of extremes, wherein they will calculate this numerator separately, then this denominator separately, then they will show, not needed. So you don't have to show detailed step by step calculations. Show the substitution and give the final calculation, final calculated value sufficient. But at the same time, you write the formula and simply give the value, that is also not so great. Okay, it's not wrong if you get the correct answers, fine, but then we should also know that what you have used is correct values. How do we know whether what you have, whether you have taken the correct values only, or you have seen somebody else's answer and written the answer? We would not know. Okay, but at least if you substitute the values in the equation and then do the calculation in one go and write the final answer, that is sufficient. Okay, so this is the general process. That's why I have shown the way you should be doing it in your for example, you don't have to show this like here, where is it, here like 100 and 200, this is 2, so not needed. Very very primitive, very like high schoolish kind of a thing, not needed. This also you need not bother about showing the subtraction in the numerator and then writing, not needed. Finally you should write the answer. We will know that internally you would have done these things, obviously. That's a given. Okay, so these are all some of the things that you people should remember and do. Now what, I think we are closing to the end of the session. What I'll do is I'll leave you people with a few more questions. We will take it up in the next class. And by the way, I hope you people know that next class is not tomorrow. You have got the changed timetable.
Yes, sir.
Yes, sir.
When is the next class?
Thursday, first hour, I think.
Yeah, tomorrow's
Or
session has been moved to Thursday first hour, but that doesn't mean that we have next class on Thursday only. We have our regular class on Wednesday. So Wednesday, 11:15, 2 hours slot, whatever we have, we will meet on that particular day. So when we meet, we will discuss these questions. So take down this one of the questions. Okay. Similarly, one more question. I'll just anyway, I'll share this with you, but I'm just giving it for your reference here. Okay. One more question. So I generally follow this method. I don't dictate questions, since in the see, if it was next, if it was physical class, I would have dictated these questions because we had no other option. But since it's an online class, you can always just give the typed question, so that it is easier for it. We consume less time. Okay, so I'm leaving you people with these two questions. I will share this particular, anyhow. I keep sharing the write-ups, so you will get this particular document by today. You can just try to attempt these two questions and come prepared for the next session. Okay, is it fine?
Sir, for any
sir,
doubts, we
one
should.
I should scroll down. Yeah. Who? Yeah. Tell me.
sir,
Sir,
one
for
small doubt regarding terminology.
Yeah.
If the question were calculate